even with just one subscriber. I still want to take a shot at something ambitious. Trying to explain something usually reserved for huge channels. A deep dive into general relativity. I feel confident about this topic because it has opened the doors to spacetime for so many people. And back when I was lost on my path as a science creator, it pushed me to start sharing the universe with everyone. If this video actually takes off, the comments section will be flooded with physics geeks, all talking about how general relativity impacts their lives. For those who pulled all-nighters to grasp spacetime curvature, many people find their first encounter with general relativity to be incredibly abstract and confusing. Some even scroll past when they see those dry equations. But for those who truly dive in, it hits home at some point. Some have reshaped their view of spacetime. Others have fallen in love with theoretical physics. And some have actually started to ponder the possibilities of time travel. Our protagonist is Albert Einstein. Just an ordinary clerk at the patent office, with no laboratory, no assistants, and absolutely no one believed in him. But this very man, with nothing but a pen and paper, derived the field equations in 1915 and brought down the 300-year-old physics empire of Newton. His core conclusion is simple: mass warps spacetime, and what we perceive as gravity is just the shape left behind by this curvature. Sounds abstract, right? Let me give you an analogy. Lay a mattress flat on the ground. Place a bowling ball on it. The mattress will sag. Now if you place a marble nearby, it will slide toward the bowling ball. You might think the ball is pulling the marble, but in reality, the bowling ball just changed the shape of the mattress, and the marble is just following that curve. The Earth orbiting the Sun is not because the Sun is pulling us, but because the Sun has warped the spacetime around it, creating a massive dip. And we are just rolling around in that dip. So gravity is not really a force. It is just the geometry of warped spacetime. Curved space is easy enough to grasp. The part that really blows your mind is time curves too. General relativity tells us the stronger the gravity, the slower time moves. This is no metaphor. It is a proven physical fact that happens every day. When you take out your phone and open the navigation app, you are relying on GPS satellites orbiting 20,000 kilometers above the ground, where gravity is weaker than on Earth. Time moves about 38 microseconds faster every day. If engineers did not correct this error daily, your navigation would drift by over 10 kilometers in a year, leading you straight into the wilderness. Every time you use a map, you are actually benefiting from the precision backing of general relativity. If time curves, then what actually is time? There is a conclusion here that might really shake you up. Time might not exist at all. It does not mean time has stopped. It means time never flowed in the first place. General relativity combines time and three-dimensional space into a four-dimensional structure known as the block universe. In this structure, the past, present, and future are not a linear timeline unfolding, but exist simultaneously within the universe. Like different coordinates on a map. They are at different locations, but they are already there. A summer afternoon in your childhood. This very second as you stare at your screen. And your sigh in the middle of some future night. In the four-dimensional spacetime, they all coexist, just at different coordinates. So why do we feel time flowing? Because of entropy. Systems in the universe spontaneously move from order to disorder. Stars burn out. Black holes evaporate. A cup of hot water cools down, but it will not heat itself back up. Our brains are information recorders. Memories can only be written in the direction of entropy. From low entropy to high entropy. From order to disorder. So we can only remember the past. And only predict the future. Which makes us mistakenly think time is flowing. But time itself is not going anywhere. What is moving is our brain information processing. The sense of time flow is just an illusion of our consciousness, scanning through this static axis frame by frame. Just like a movie film. Every frame is already printed on the reel, and the projector plays them one by one. Which is why you feel the story developing. This conclusion leads to an even scarier question. If spacetime is static, is every choice you make right now truly a choice? Or was it written long ago? Every coincidence you think you encounter, every turning point, might just be an inevitability on a predetermined path in spacetime. Free will might just be an illusion. But quantum mechanics offers another possibility. The many worlds interpretation suggests that whenever a quantum event happens, the universe splits into multiple parallel branches, where all possibilities play out in different branches. Combine this theory with the block universe. Spacetime is not just static. It is branching and static. Countless parallel four-dimensional time axes exist simultaneously. Everything you experience on this axis is just one of many possibilities. Perhaps the version of you that made a different choice is living on another time axis right now. Free will feels like improvisation in a script. But from a higher dimensional perspective, it is still part of the script. So what about time travel? General relativity has already given us the answer. Traveling to the future is genuinely possible. There are two ways. Speed. The faster you move, the slower time goes. Astronauts on the International Space Station, moving at high speeds, upon returning to Earth, will be a few milliseconds younger than people on the ground. This is a real-time difference. Not an error. Not an illusion. Gravity. Get close to a massive celestial body, and time will be slowed significantly. Theoretically, if you hover for an hour at a safe distance near a black hole, upon returning to Earth, decades might have passed. Your parents are older. Your friends are gone. But you are exactly as you were. Not a single gray hair more. In the movie Interstellar, the protagonist lands on a planet near a black hole and stays for 3 hours.